In the previous video, we had learned about the various energies of orbitals. In this video, we are going to be learning about the various rules for filling electrons. So there are three rules. First is the Aufbau Principle. The second is the Pauli's Exclusion Principle. And the third is the Hund's rule for maximum multiplicity. So let's start with the Aufbau Principle. Aufbau Principle states that, first of all, the word Aufbau means in German means building up. So this means that the filling up of the orbitals with electrons is what is the basis for this particular rule. So in the ground state of the atoms, the orbitals are filled in order of their increasing energies. Now, if you remember, we had learned that we learned about the various energies of our orbitals in the previous video. So based on the rule of, or rather based on the Aufbau principle, the least energy orbital will get filled, and then it will go on to the higher one, and then a higher. So suppose we're taking, this can be remembered with respect to this diagram. So 1s orbital will get filled first, then the 2s orbital, then 2p, then 3s, then 3p. One would think they'd go to 3d, right? No, but we'll start with 4s, which has a lower energy compared to 3d, which is at a higher energy. So it goes from 4s, 3d, 4p, 5s. Again, we won't go to 5p, we will go to 4d, 5p, 6s, and then 6s does not go to 6p. Here you have the 4f orbital coming in. So 6s, 4f, 5d, 6p, 7s, 5f, 6d, and 7p, and so on. So this basically gives us the idea about the energies. The lower energy will be filled first, then the next one will be the higher energy, and it will be going on with as it follows. Okay, so for example, in potassium, the valence electron has the option to fill in to either 3d or 4s. And it was observed that the electrons fill into 4s first, and then, for potassium, they fill into 4s. Then after that, the various elements coming after potassium, they start filling into 3d. So this is the basis of the Aufbau principle. Second is the Pauli's exclusion principle. This was given by Wolfgang Pauli in the year 1926, who was an Austrian scientist. So according to him, no two electrons in an atom can have the same set of 4 quantum numbers. As we had discussed the various quantum numbers, we had the principal quantum number, the azimuthal quantum number. The third is the magnetic quantum number, and the fourth is the spin quantum number. Now, when we consider electrons, no two electrons will have all the 4 quantum numbers at the same. It might have the same principal, azimuthal, and even the magnetic, but it will vary at least with the spin quantum number. This because in an orbital, 2 electrons cannot have the same spin. It lead to a lot of repulsion, and this particular orbital will become unstable. Not only that, the maximum number of electrons in a shell with the principal quantum number n equals to 2n square. So this is basically gives us the idea. Suppose we have principal quantum number as 1. Okay, this shell can have only 2 electrons because 2 into 1 square. So, and if you remember, we had learned that our 1s can only house 2 electrons. Similarly, for 2 into 2n square, 2 square, which is nothing but 8 electrons. So 6 plus 2 equals to 8. Similarly, 3 3s are 9, 9 2s are 18. So 6 plus 2 is equal to 8, 8 plus 10 equals to 18. So according to Pauli's exclusion principle, the maximum number of electrons in a shell with the principal quantum number n equals to 2n squared. 2n squared is the maximum number of electrons that can be filled into that particular shell. The third is the Hund's rule of maximum multiplicity. Now, if you have The pairing of electrons in the orbital belonging to the same subshell does not take place until each orbital belonging to that subshell has gotten one electron each. So, we will be doing the electronic configuration again in detail. But for example, we will take the example of nitrogen. Okay, nitrogen's atomic number is 7. Yeah, 7. So in the according, or rather, once again, leave the nitrogen out of this. So suppose we have a p orbital. Okay, we will not be filling the electrons like this. No, we will first pair up the first fill in the electrons in all the 3 subshells. Forgive me for this horrible drawing. We will be dealing with this again. So first we will fill in half of this shell, and then the electrons will start pairing up. So suppose we had 4 electrons. If I had done just paired it up like this, it would have been wrong. It should be filled half, and then it will start pairing up. That is the basic idea behind Hund's rule of maximum multiplicity. Don't worry, we will be doing we'll be doing the electronic configuration of various atoms in the next video. So in this video, we had learned about the Aufbau principle, Pauli's exclusion principle, and Hund's rule of maximum multiplicity. We will be applying these 3 rules to the to write down the electronic configuration of various elements, and that is discussed in the next video. Do check it out.